it's called a ratio. And a ratio is a comparison of two numbers. Ratios can be fractions, decimals, percents. We're going to talk a little bit about ratios, but first, I'm going to just show you some ratios from around my house. This belongs to my husband. It hangs beside our pool table, and we could say the ratio of pool chalk to pool balls is 1 to 3. Here are some seashells from my bathroom. The ratio of starfish to not starfish is 1 to 4. The ratio of smooth to not smooth is 1 to 4. We could do the ratio of white to dark. So these three I would classify as white, and these two would be dark. So we could say the ratio is 3 to 2. This is a pinball machine that my husband has in our basement. And there's a ratio listed right on it. 1 to 1 is your play for your quarter. We could say the ratio of balls per game is 5 per 1. This is actually a unit rate, which we're going to get to in our next video. And we could say the ratio of basketball to baseball. Well, this is basketball, and this is basketball, and this is basketball. So it's 3 to 1 baseball. So, hopefully with a little trip around the basement where I make my videos, you've seen that there can be lots of things that are ratios. Ratios are simply comparing, and ratios can be written as a fraction. Let's do people to dogs in Mrs. E's house. There are 4 people that live in my house, and there are 2 dogs that live in my house. So the ratio of people to dogs in this house is 4 to 2, written as a fraction. 4 to 2, written with a colon, or 4 to 2, written with the word 2. Ratios can be written 3 ways. Let's talk about the kind of questions that you might be asked using ratios. This is a chart about the boys and girls in 6th grade at LCA. There are 70 boys and there are 60 girls. And so if I said to you, what is the boy-girl ratio? You could say 70 to 60. But with fractions, ratios are very commonly expressed in simplest form. And like fractions, ratios can be found on a multiplication chart. So if I were to try to do 70 to 60, I could simplify this by dividing both of them by 10. And the ratio in simplest form is 7 to 6. If my ratio is 7 to 6, then I could write it 3 ways. 7 to 6, 7 to 6, or 7 to 6. Now let's answer these 2 questions using these numbers. What is the boy to all ratio? So I'm going to go find my boy number, which has to be first. 7 boys to all. Well, how many are there in all? Well, if this is 6 and 7, then we would say the boy to all ratio is 7 to 13. Or down here it would have been 70 to 130. But again, a simplified ratio is easier to understand. So what's the girl to all ratios? The girl to all ratios is 6 to 13, which means for every 7 boys, there are 13 students. For every 6 girls, there are 13 students. That kind of information would allow you to have a 7 to 6 ratio. ratios are very often used as test grades, which you have called fractions. And that's not incorrect. This is 18 out of 30. Sometimes a ratio compares part to a whole. When it compares part to a whole, it is a fraction. Sometimes a ratio compares part to a part. That's when it's a ratio and not a fraction. So if I were to write at the top of your math quiz paper how many you got right and how many you got wrong, that would be a ratio. But instead I write how many you got correct out of how many total there were. That's how most grades are done. So ratios can be part to whole or part to part. Comparing ratios, you're going to use the same skills you learned in your fraction unit. In order to figure out which of these quizzes has the best ratio, we want to see which one has the highest percentage. And so we would convert these to percents. We can do that from the stage they're in, or we could simplify these ratios. Just for some practice simplifying and understanding equivalent ratios, let's do that first. So let's use this ratio chart, or this multiplication chart, or this fraction chart. Hopefully you're seeing that this has a lot of uses. And let's find 18 and 30 in the same row. And if you see here, this is 18 and here's 30. And if I slide my fingers, my simplified ratio is 3/5. So for every 5 questions that were on this student's quiz, 3 of them were correct. On their science quiz, let's find 24 and 36 in the same row, which is here. Here's your 24, here's your 36. So on this test, every 6 questions that there were, they got 4 correct. And in order to figure out which test they did better on, we're going to turn both of these into percentages, which means that we're going to remember that we're going to tip it over and divide it out. The numerator is on the inside because the numerator starts with n, and this is called the inside. And so 0.6 is my decimal. In order to convert a decimal to a percent, you move it twice to the right. And 60% is what was scored on the math quiz. 4 out of 6. I'm looking at a repeating decimal, which means that this student has a 0.6 repeating. And when this teacher scores this test, this teacher will round it to a 67%. If you're looking for the true percent, you would call it 66.6 repeating percent. We have compared ratios by using exactly what we did with fractions. These are the things I'm hoping you remember from this video. So it's time to show what you know. What is a ratio? A ratio is a comparison of 2 or more things. We can have ratios for more than 2 things. So I could do the ratio of boys to girls to dogs in my house. It just so happens there's 2 of each, so that ratio would be 2 to 2 to 2. But a ratio is a comparison of numbers, can be fractions, decimals, or percents. Hopefully you have that in your notes from the first slide. Write the ratio of blue to red 3 different ways. Well, even though the red comes first here, because this says blue to red, I have to write with the blue number first. So 1 to 2, 1 to 2, 1 to 2. Simplify each ratio. So this is a ratio of 9 boys to 90 girls. 9 to 90 could simplify to a 1 to 10 ratio. 15 to 12 could simplify to a 5 to 4 ratio. Write an equivalent ratio for each, And remember, writing equivalent ratios means that you can slide your fingers either way. So if I find the 3 and the 5, I could write 6 to 10, 9 to 15, 12 to 20, 15 to 25, 18 to 30. The possibilities are endless. 7 to 3. Here's the ratio of 7 to 3. 14 to 6, 21 to 9, 28 to 12, 35 to 15, 42 to 18. As long as you're multiplying the top and the bottom by the same number, you are writing an equivalent ratio. And finally, an equivalent ratio for 5 to 4. Do the same thing. Look straight down here in the middle of our chart. 5 to 4 is 10 to 8, 15 to 12, 20 to 16, 25 to 20.